Unexpectedly, cosmic events of extraordinary scale happen billions of kilometers from Earth, reverberating all through the universe. As of now, a comparable event is drawing nearer, causing shock even among specialists. A red giant star, positioned at the outer edges of our solar system, is sending ominous signals across the universe, detected by the James Webb Space Telescope. Cosmologists have uncovered deeply disturbing revelations about this epic, glorious body. As renowned astrophysicist Brian Cox issues a grave warning, a pressing question arises. Are we on the verge of witnessing a shocking astronomical explosion that could forever change the night sky? Before diving into further details, be sure to subscribe to our channel if you haven't already. Now, the burning question remains, will this impact Earth? And will it be visible from our planet? Stay tuned as we explore the answers to these compelling questions in this video. In the vast expanse of the universe, where the cycle of stellar birth, life, and death unfolds in mesmerizing wonder, one particular star has recently captured the attention and concern of both astronomers and the general public. This star, known as Betelgeuse, stands out prominently as a red supergiant in the Orion constellation, boasting an immense size and age. While its striking bronze hue and fluctuating brightness have long fascinated observers, recent events have further heightened interest in this magnificent behemoth. As we delve into the nature of Betelgeuse, we find ourselves on the brink of a potentially astounding event in its stellar life cycle. But what do these changes in Betelgeuse's behavior mean? Could we be witnessing the beginning of a historic, dramatic event of unimaginable magnitude? Betelgeuse, with a size more than 1,000 times greater than our Sun, remains a colossal giant among stars. Its sheer size stretches the limits of human imagination. Imagine a star so massive that if it were to replace the Sun, its surface would extend beyond Mars' orbit, engulfing Mercury, Venus, Earth, and Mars within its vast embrace. This immense size not only highlights Betelgeuse's status as a true giant, but also signifies its place in the stellar life cycle. As a red supergiant, Betelgeuse is in the twilight phase of its existence, marked by expansion and cooling after a lifetime of fusing hydrogen into helium at its core. Questions arise about Betelgeuse's age. Despite being relatively young in human terms, estimated at around 8.5 to 8.8 million years old, it is quite old within the context of stellar lifespans. Its current status as a red supergiant represents the culmination of millions of years of stellar evolution, characterized by dramatic transformations from a hot blue star to the colossal red giant we observe today. The journey of stars like Betelgeuse unfolds as a continuous process of change, driven by the relentless forces of nuclear fusion and gravity. One of Betelgeuse's most distinctive features in this stage is its striking red hue. This deep red coloration arises from its relatively cooler surface temperature compared to stars like our Sun. While the Sun shines at approximately 5,500 Kelvin, Betelgeuse's surface temperature is cooler, at around 3,500 Kelvin. This lower temperature allows Betelgeuse to emit light in shades of red. However, this color is not just an aesthetic trait. It provides crucial insights into the star's physical state and the ongoing processes within its vast gaseous layers. Adding to the intrigue surrounding Betelgeuse is its remarkable color history. Ancient records from Roman and Chinese sources suggest that nearly 2,000 years ago, Betelgeuse appeared yellow. It wasn't until the 9th century that Arabic astronomers described it as red. This historical shift in color is not merely an anecdote in astronomical records. It serves as a key indicator of the star's transformative journey. Betelgeuse's fluctuating brightness adds another layer of fascination. It is classified as a semi-regular variable star, meaning its luminosity undergoes periodic variations. This dance of brightness has captivated astronomers and stargazers for centuries. Typically, Betelgeuse follows a 400-day cycle, alongside a longer 5-year cycle, noted as early as 1836 by Sir John Herschel and possibly much earlier in indigenous oral traditions. However, what truly sets Betelgeuse apart is not just its shifting brightness, but its unpredictability. Unlike many stars that follow consistent dimming and brightening patterns, Betelgeuse sometimes deviates from its usual rhythm. This irregularity points to complex and less understood processes occurring within its massive structure. Recent significant discoveries have captured the attention of astronomers worldwide. In late 2019, Betelgeuse experienced a dramatic and unexpected change, now widely known as the Great Dimming. At the time, Betelgeuse, the brilliant red supergiant in the night sky and a striking feature of the Orion constellation, began to mysteriously dim. The dimming was so pronounced that it lost brightness at an average rate of 0.01 magnitudes per day, reaching its lowest luminosity by February 2020. Normally visible to the naked eye even amidst light pollution, Betelgeuse faded so significantly that even amateur observers could notice the change. However, studying Betelgeuse presents a fundamental challenge: the time delay problem. When we observe a star like Betelgeuse, we are not seeing its present state but rather its past, due to the time it takes for light to travel to us. Since Betelgeuse is located approximately 725 light-years away, the light we see today left the star nearly 7 centuries ago. This time lag complicates efforts to predict and track sudden changes in a star's behavior, as we are essentially observing events that occurred in the distant past. The dimming of Betelgeuse serves as a stark reminder of the inherent complexities in astronomical observations and the limitations of our understanding when grappling with the vast scales of the universe and the mysteries of time. The captivating journey of Betelgeuse's astronomical performance was meticulously observed by Andrea Dupree, the Associate Director of the Center for Astrophysics at Harvard and Smithsonian, along with her team. Using the Hubble Space Telescope, they conducted a 3-year study to monitor changes in Betelgeuse's outer environment. These observations provided an unprecedented understanding of how a variable star like Betelgeuse behaves, with its characteristic expansions and contractions leading to fluctuations in brightness. Hubble's remarkable sensitivity to ultraviolet light allowed researchers to probe the layers above Betelgeuse's surface, which were slightly heated by the star's turbulent convection cells. Moreover, a detailed analysis of Hubble's spectra, collected at various intervals throughout 2019 and 2020, enabled the measurement of material movement within Betelgeuse's outer atmosphere. Specifically, the study focused on the magnesium-2 lines in the spectra, which offer insights into the star's atmospheric conditions. These observations revealed material traveling at speeds of around 200,000 miles per hour from Betelgeuse's surface into its outer layers. This heated and dense material eventually expanded millions of miles from Betelgeuse, forming the precursor to the dust cloud responsible for the star's dimming. Dupree and her team estimated that during the 3-month event, nearly twice the usual amount of material was ejected from Betelgeuse's southern hemisphere. As Betelgeuse ejected a significant amount of material into space, the expelled gas rapidly cooled, condensing into a massive dust cloud that temporarily obscured the star's light from our view. This unexpected event left astronomers puzzled. Was this a sign of an imminent supernova, or was it simply an unusual phase in Betelgeuse's late-stage evolution? To answer these questions, scientists turned to powerful observatories, including NASA's Hubble Space Telescope and the James Webb Space Telescope, JWST. Their observations confirmed that Betelgeuse's outer atmosphere had undergone an extreme convective event, where a massive upwelling of hot gas from deep within the star's interior disrupted its surface, triggering the large-scale mass ejection. Is Betelgeuse on the brink of a supernova? One of the most pressing questions in modern astronomy is whether Betelgeuse is on the verge of going supernova. Given its current stage as a red supergiant, it is certainly in the final phase of its stellar evolution. However, predicting exactly when it will explode remains challenging. In cosmic terms, a supernova could happen within the next few thousand years, or even within our lifetime. When it does occur, it will be a breathtaking spectacle, likely visible even during the daytime for weeks or months. The explosion will unleash an immense burst of energy, briefly outshining the entire Milky Way before gradually fading away. But will this supernova pose a threat to Earth? Fortunately, astronomers believe we are at a safe distance, about 725 light-years away. Although the explosion will release high-energy radiation and cosmic particles, Earth's atmosphere and magnetic field will provide ample protection against any harmful effects. What's next for Betelgeuse? As astronomers continue monitoring Betelgeuse with cutting-edge telescopes, they are eager to uncover more details about the processes driving its unpredictable behavior. Future observations with JWST and other high-resolution instruments will help scientists determine whether additional mass ejections or dimming events are on the horizon. For now, Betelgeuse remains a fascinating enigma, a star on the edge of transformation, keeping scientists and stargazers alike on the lookout for what may be one of the most extraordinary astronomical events of our time. Stay tuned for more cosmic discoveries. If Betelgeuse does go supernova within our lifetime, it will be one of the most visually spectacular events ever witnessed by humanity. Until then, astronomers will continue unraveling the mysteries of this colossal red giant, waiting for the day when the night sky is forever changed by its brilliant farewell. Stay curious, keep looking up, and subscribe for more updates on the latest astronomical discoveries. This critical mass misfortune is especially outstanding since, like all stars, scarab Jews consistently shed mass, yet at a much higher rate than our Sun. The size of this mass discharge and the subsequent darkening flash have sparked conversations among space experts concerning whether this event could signal a looming cosmic explosion. The blast in the vicinity of Betelgeuse, found about 725 light-years from Earth, adds to the interest. If such an explosion were to happen, it would be apparent from Earth, presenting an intriguing opportunity to closely observe a cosmic explosion. However, the question persists: what does this diminishing event mean for creepy, crawly Jew's future? Does it signal a forthcoming cosmic explosion, or is it only a transient stage in the star's huge and complex journey? Different speculations have been proposed to shed light on this phenomenon. One hypothesis suggests it's a phase in the cosmic explosion process, gaining traction due to the widespread belief that creepy, crawly Jew is approaching the end of its life cycle. Another broadly accepted speculation involves dust, potentially originating from the star itself, obstructing our view of Bug Jew. A third explanation examines changes in the star's photosphere, its apparent surface layer, which could influence its apparent brightness. Extensive investigation, utilizing different observational methods, added to unraveling this mystery. Spectroscopic evaluations showed a decline in scarab Jew's effective temperature, suggesting the possibility of a critical dark spot on the star's surface. This hypothesis found support in observations revealing a temperature drop of at least 170 Kelvin during the darkening period, highlighting significant surface changes. Ultimately, the key to understanding this extraordinary phenomenon came from humankind's careful look into space via the Hubble Space Telescope. Hubble's precise observations revealed that insect Jew's dimming was likely caused by a massive ejection of heated material into space. This material coalesced to form a dust cloud, blocking some part of the star's surface and reducing the amount of light reaching us from scarab Jew. The arrangement of the dust cloud was attributed to superheated plasma, which erupted from a large convection cell on the star's surface and passed through its scorching atmosphere to the cooler outer layers. After cooling, this plasma formed dust particles, creating a cloud that blocked light from around a fourth of the star's surface. Hubble's ultraviolet light spectroscopic observations, which began in January 2019, played a crucial role in reconstructing the timeline leading up to Betelgeuse's dimming. These observations identified signs of thick, heated material passing through the star's atmosphere in the months preceding the dimming event. By December 2019, other ground-based telescopes also observed the star's reduced brightness, especially on its southern hemisphere. Initially, this material appeared brighter than the star's usual radiance, eventually resulting in the formation of a shadow as it dissipated outward and cooled. The idea was simple. This outward progression of material and the resulting shadow were responsible for the star's sudden dimming. The scale of this discharge is truly surprising, pushing Betelgeuse into the spotlight. The star expelled an estimated 400 billion times the mass typically released in a standard coronal mass ejection. This expelled material was thought to be enough to offset our moon a few times over, marking a significant event not only for creepy crawly Jews, but also for advancing our understanding of celestial mechanics. But what are the implications of such a massive release of material for scarab Jews and broader supernova theories? Conventional thinking proposes that red supergiants like Scarab Jew regularly shed mass before reaching the catastrophic peak of their existence. However, the magnitude of this discharge challenges this idea, hinting at a potentially more unstable and erratic final stage for these stars. Could Betelgeuse just be preparing for its grand finale, a supernova explosion, within the next few centuries? Recent research has speculated on the timing of such an event, suggesting it might occur sooner than previously thought, possibly within just a few years. Furthermore, the nature of the bow shock adds another crucial layer to the insect Jew puzzle. As this massive star races through space at around 67,000 miles per hour relative to its surrounding interstellar medium, it creates a bow shock similar to the wake formed by a boat's bow. This phenomenon results from the star's outer layers interacting with interstellar gases and dust, offering a spectacular display of the star's dynamic behavior and its interaction with the cosmic milieu. However, what about creepy crawly Jew's new behavior? Its surface cooling and reduced density, observed following the ejection event, leave the star in a disturbed state, even years afterward. Hydrodynamic simulations suggest a connection between the star's convective activity, the mass ejection, and the ensuing changes in its oscillation modes. This ongoing instability raises questions about the internal processes driving these changes and their potential implications for the star's future. Moreover, the observed mass loss rate of insect Jew exceeds that of many other stars, reflecting a complex interplay of internal forces. Nevertheless, with energy continually dissipating through shock heating and mass ejection, creepy crawly Jew's mood is shifting. The very nature of these mass losses points to the star's dynamic and somewhat erratic life cycle, prompting astronomers to re-evaluate their models of stellar evolution.